This video is strictly for educational purposes. Don't use these methods on networks you don't own or have permission to test. Always stay on the right side of the law. Hi everyone, welcome back to another exciting video. Today we'll explore how Wi-Fi networks can be tested for security flaws using Aircrack-ng, a tool used for understanding and securing networks. Our goal is to help you protect your systems by understanding how attackers might target them. Before we dive into the hands-on part, let's cover a few important prerequisites. First, to follow along with this tutorial, you need to have some basic knowledge of Linux commands. If you're not familiar with commands like ifconfig, iwconfig or ping, don't worry, I have already covered those in a previous video, so feel free to check it out before jumping into this one. Now, the tools you will need. For this tutorial, we will be using Kali Linux, which is my favorite distribution for penetration testing. If you don't have it installed, you can set it up easily on a virtual machine like me, and I made a video about this, you can check it. There is one more important thing, your Wi-Fi adapter. Most built-in adapters aren't suitable for what we're about to do. You will need a Wi-Fi adapter that supports monitor mode and packet injection, like Alpha devices that appears on the screen right now. By the way, Alpha didn't sponsor me to say that, but I'm using an Alpha adapter and I found it very useful and doesn't need any drivers to work. Lastly and most importantly, you'll need a Wi-Fi network that you own or have permission to test. In this video, I'll be testing my own TP-Link router to demonstrate how Aircrack-ng can be used to assess its security. To make it clear that this is my own network that I'm testing, let me show you a quick screenshot from my TP-Link router's configuration page. As you can see, the network name, Tom, matches the target network I'll be testing today. Again, this demonstration is purely for educational purposes, and I strongly encourage you to only test networks you own or have permission to test. This verification ensures that we are staying within ethical boundaries. Ethical hacking is all about securing, not attacking. Alright, let's dive into the action. Start by checking if we have Aircrack-ng installed. I will type the command aircrack-ng, and as you can see, it's not installed on my system. This is a great opportunity to show you how to install it. It's very easy. The terminal is asking if I want to install the package, so I'll just type Y here to confirm. Once that's done, we're good to go. Next, let's check if our Wi-Fi adapter is properly connected. We'll use the command iwconfig. Right now, I don't have my Alpha Wi-Fi adapter connected with this Kali Linux machine, so it's not showing up in the list. I'm going to connect the Alpha Wi-Fi adapter now through the USB. Watch closely and you will see an icon pop up in the bottom right corner of VMware. This little USB icon confirms that our adapter is recognized. Now, a quick note here. If VMware asks whether you want to connect the adapter to your virtual machine or the host, make sure to select the virtual machine. Let's check again using iwconfig to make sure the Wi-Fi adapter is recognized and connected. As you can see, our adapter is all set. Now, before we proceed, there is an important step we need to take. We need to kill any processes that might interfere with our wireless monitoring. To do this, we'll run sudo airmon-ng check kill. This command is vital because background processes like network managers can disrupt monitor mode, which we will be using to capture Wi-Fi traffic. Now, let's talk about the difference between managed mode and monitor mode. Normally, your Wi-Fi adapter operates in managed mode, which means it's connected to Wi-Fi network and communicates with an access point. But to capture all the wireless traffic around us, we need to switch to monitor mode, which allows our adapter to listen to all wireless traffic in range. It's like switching from being a participant in a conversation to just quietly listening on everyone around you. Let's switch our adapter into monitor mode by running sudo airmon-ng start and then your wireless interface, which is WLAN 0. This command activates monitor mode on our adapter. Great. Now let's verify that it is in monitor mode. I will use iwconfig more time. As you can see, the name has changed to WLAN 0 mode, which refers to monitor mode, which means it's ready to capture wireless traffic. Let's clean up the terminal by typing clear to start afresh for the next steps. Alright, now that we have our Wi-Fi adapter in monitor mode, it's time to start scanning for networks. To do that, we'll run the command sudo aircrack-ng and the name of the wireless interface, which became WLAN 0 mode. This will show us all the nearby Wi-Fi networks and devices that our adapter can detect. Let me quickly break down the columns you are seeing here. Starting from the left, we have the PSSID column, which is the MAC address of each network. Then, there is the PWR column, which shows the power or signal strength of each network. A lower number here means a stronger signal. The beacons column tells us how many beacon frames the network has sent out, while the data column shows the amount of data packets captured so far. Next, we have the CH column, which represents the channel each network is operating on. Then, we'll see the megabyte column, showing the maximum speed supported by the network, followed by ENC, which shows the encryption method being used, for example, WPA or WPA2. Lastly, we have the ESSID, which is just the network's name. In my case, I'm looking for my network, which I have named Tom. Now, a cool feature of aircrack-ng is that you can sort the results based on any column you want. By pressing the S key, I can sort by the PSSID, power, or any other factor. Let's go ahead and hit S a few times so you can see how it works. You can see the order changing each time I press it. This can be helpful if you want to sort by signal strength. Another useful feature is the ability to filter what you see. By pressing A, we can toggle between showing just access points, just stations, which are devices connected to network, or both. Now, let's stop the scan since we found the network, which is my own network, Tom. I'm just testing this, and I want to remind you that everything in this video is for educational purposes only. To stop the scan, I press Ctrl+C. Now that we have detected the network and gathered its information, let's move forward in the new terminal window. I'll start by moving to my desktop, where I want to keep everything organized. CD Desktop. We're now on the desktop. I'll create a new folder to store all the captured files and the dictionary we'll use later. I'll call this folder Test. Now, let's move into that folder, CD Test. Great! This will keep everything clean and separate from our system files. Now, let's start capturing packets from our target network. We already know it's PSSID, which is like the MAC address of the router. And we know the channel it's operating on, which is channel 11 in my case. To start capturing, we will use this command. Let's break this command down. The -w target part tells aircrack-ng to save the captured data to a file called target. You can name it anything you want. The -c11 part specifies the channel, which in our case is 11. The --BSSID option is where we provide the BSSID or MAC address of the network. Finally, WLAN 0 mode, which is our wireless interface in monitor mode. The goal here is to capture a crucial part of Wi-Fi security called the four-way handshake. So, what is this four-way handshake? Let me explain. Technically speaking, the four-way handshake is a series of message exchanged between a Wi-Fi access point and a device, like your laptop or phone. When they are establishing a secure connection, this is where the network and device authenticate each other and generate encryption keys that will be used to encrypt the data passing through the connection. By capturing this four-way handshake, we get enough information to attempt cracking the password later. And remember, it's crucial to only do this on networks you own or have permission to test. Right now, the capture is running and we are waiting to capture that handshake. Now that we are capturing packets and have our target network inside, the next step is to speed things up by forcing the devices connected to the network to disconnect and reconnect. This will help us capture the four-way handshake faster. We can achieve this by running a deauthentication attack using the Aircrack-ng command. In this terminal, I'm going to run the following command. Let me break it down. The --deauth0 option means we are sending deauthentication packets continuously. The 0 means no limit, so it keeps sending until we stop it manually. The -A option specifies the BSSID or MAC address of the target access point. And WLAN 0 mode is our wireless adapter in monitor mode. Before we run the command, I'll open another window showing my mobile screen, which is currently connected to the target Wi-Fi, which is mine. This will help us to see how the attack affects the devices on the network in real time. Let's hit enter and see what will happen. Now, the deauthentication attack is running. As you can see, my mobile is now disconnected from the network. And every time I try to reconnect, it fails, because the attack is continuously sending deauthentication packets to the router. This is how DOS attack works. It prevents devices from accessing the network temporarily. In a real-world example, a DOS attack is like flooding someone's inbox with emails so quickly that they can't keep up. Their inbox becomes so full of messages that they can't see or respond to any real emails. Similarly here, the router is being flooded with deauthentication requests, preventing it from keeping devices connected. At the same time, if you look back at the terminal window where we're monitoring the target network, you will notice the message WPA handshake has appeared at the top. This means we have successfully captured the four-way handshake, which is exactly what we were aiming for. Now that we have that, we can stop the attack. Let's stop the deauthentication attack by pressing Ctrl+C. And now, if you look at the mobile screen again, you will see that I can successfully reconnect to the network since the attack has stopped. Next, let's stop monitoring the network since we've captured what we need. To do that, I'll press Ctrl+C in the window where we're capturing packets. Now, it's important to return our wireless adapter back to managed mode so it can function normally. I'll open a new terminal window to make things clear. And to return to managed mode, we'll run sudo rmon-ng stop WLAN 0 mon. This command stops monitor mode on our wireless adapter. Let's check to make sure the adapter is back in managed mode by running iwconfig again. As you can see, the adapter is back in managed mode, which is its normal state. Let's clear the terminal to clean things up. Next, since we ran sudo rmon-ng check kill earlier, which killed some network processes, we need to restart our network manager to get everything back to normal. We do that by running service network manager restart. This will ensure our network services are working properly again. And finally, let's clear the terminal again. Now that we have captured the handshake, the next step is to crack the password using a wordlist. First, let's check if we have wordlist installed. We will type wordlist to see if it's available. As expected, the terminal is asking if I want to install it. So let's go ahead and type Y to proceed. While that's installing, let me explain what word lists are. A word list is essentially a dictionary of possible passphrase, which we use in a dictionary attack. In this type of attack, the cracking software compares each passphrase in the list against the captured handshake until it finds a match. One of the most famous word lists is ROCU. It contains about 14 million of the most commonly used passwords around the world. Now that the installation is complete, let's clear the terminal. Next, let's navigate to the folder where these word lists are stored by typing cd user share word lists. If we list the contents of this folder by typing ls, you'll see the file we are going to use called rocu.txt.gz. This is a compressed file. We will copy the file to our project folder on the desktop where we have the captured handshake files. This keeps everything organized in one place: cp, rocu.txt, and the path. Now let's navigate back to our project folder. We will check to make sure the file copied successfully by running ls. As you can see, the rocu.txt.gz file is here. Let's now extract it using the gunzip command. Let's check again with ls to make sure the file has been unzipped. Now we have the uncompressed rocu file, which contains around 14 million of the most commonly used passphrase. It's incredible to think how many passwords out there are vulnerable because people use simpler or common phrases. Make sure to avoid using predictable passwords like 1234 until 6 or password or anything like that. And if you are a Real Madrid fan, as we'll see in a bit, it's probably not a good idea to set your password to Real Madrid. Now, let's use the Aircrack-ng command to start cracking the password. We will be using the capture handshake file and the rocu.txt word list. By this command, Aircrack-ng, and then the file name with .cap extension, -w, and the word list, which is rocu.txt. Let me explain what this command does. Test-01.cap is the file where our captured handshake is stored, and -w rocu.txt specifies the word list we want to use. Essentially, Aircrack-ng will go through each passphrase in the word list and compare it to the handshake until it finds the correct one. As you can see, Aircrack-ng is now processing each password in the word list. Depending on the complexity of the password, this could take some time. We will let it run, and as soon as it finds a match, it will display the password. There it is. We found the password when the cracking process reached 9.95%. The password is Real Madrid 1902. And actually, that is my password of my router that I set before. Let this be a reminder. We all like Real Madrid, but even if you are a huge fan of your favorite team, you should still use complex password to protect your network. Now, let's test this password to make sure it works. I will make my device forget the Wi-Fi network and then reconnect to it using the cracked password. As you can see, I have successfully reconnected to the Wi-Fi network with the password. And that's it for today's video. As you have seen, using common passwords can leave your network vulnerable to attacks like this one. This is why it's so important to use strong and complex passwords that are hard to guess or crack using word list. If you found this video helpful, hit that like button and consider subscribing to the channel for more ethical hacking tutorials and cybersecurity tips. Until next time, stay safe, stay secure, and always protect your networks with strong passwords. Thanks for watching and see you soon.